Two types of bacteria commonly found in the gut work together to fuel the growth of colon tumors, researchers reported on Thursday. Their study, published in the journal Science, describes what may be a hidden cause of colon cancer, the third most common cancer in the United States. The research also adds to growing evidence that gut bacteria modify the body's immune system in unexpected and sometimes deadly ways. The findings suggest that certain preventive strategies may be effective in the future, like looking for the bacteria in the colons of people getting colonoscopies. If the microbes are present, the patients might warrant more frequent screening. Eventually, people at high risk for colon cancer may be vaccinated against at least one of the bacterial strains. I can't guarantee you these bacteria will be the holy grail of colon cancer, but they should be high on the list of possible culprits, said Christian Joben, a professor of medicine at the University of Florida who studies bacteria in the gastrointestinal tract. An estimated 50,000 Americans are expected to die of colon cancer in 2018. The new study focused on the earliest stages of the disease. Two types of bacteria, Bacteroides fragilis and a strain of E. coli, can pierce a mucus shield that lines the colon and normally blocks invaders from entering, the researchers found. Once past the protective layer, the bacteria grow into a long, thin film, covering the intestinal lining with colonies of the microbes. E. coli then releases a toxin that damages DNA of colon cells, while B. fragilis produces another poison that both damages DNA and inflames the cells. Together they enhance the growth of tumors. Not everyone carries the two types of bacteria in their colon. Those who do seem to pick up microbes in childhood, where they simply become part of the diverse mass of bacteria in the intestinal tract, the so-called microbiome. For most who carry them, it is not clear the bacteria would ever be a problem, said Dr. Eric Palmer, an infectious disease specialist at Memorial Sloan Kettering Cancer Center in New York. The bacteria seem to be able to induce colon cancer, or to take precancerous cells and drive them faster toward cancer, said Dr. Drew Pardall, director of Johns Hopkins's Bloomberg Kimmel Institute for Cancer Immunotherapy and an author of the new paper Bacteria Are There at the Very Earliest Stages, said Dr. Matthew Meyerson, director of cancer genomics at the Dana-Farber Cancer Institute in Boston. This is a big step forward in understanding what is the role of the microbiome in colon cancer. The study's lead researcher, Dr. Cynthia Sears, an infectious disease specialist at the Bloomberg Kimmel Institute, did not expect to be investigating colon cancer. She and her colleagues were looking at a toxin that is produced by B. fragilis. It was a familiar poison, a common cause of diarrhea. In petri dishes, however, the toxin damages DNA and triggers cancerous changes in the epithelial cells that give rise to colon cancer. When the investigators put these toxin-secreting bacteria into mice, the animals' colons became spotted with tumors. So the scientists decided to investigate a broader question: were any bacteria linked to human colon cancer and, if so, which ones? The scientists chose to focus on two groups of patients, those who had no particular genetic risk for colon cancer but developed it anyway, and those who had a rare inherited genetic condition, familial adenomatous polyposis, or FAP, that almost inevitably leads to colon cancer. In both groups, cancer begins with polyps, benign growths of colon cells that carry a mutation or two that can set them on the path to cancer. Most of the time, however, the polyps never progress and remain harmless. But if a polyp develops a few more mutations, cancer can begin to develop. So to protect patients, doctors remove any polyps they find during a colonoscopy. People with FAP can have hundreds of polyps, their colons lined with growths. It is impossible for doctors to take them all out. Instead, they may remove the patient's entire colon. Dr. Sears and her group examined 6 whole colons lined with polyps that had been removed from people with FAP. The researchers discovered biofilms, sheets of bacteria that had invaded the mucus covering the colons. But the biofilms were made up of just 2 species of bacteria, B. fragilis and a strain of E. coli. In samples of colon tissue from healthy people, only a few had these bacteria. The researcher also examined 25 tumor samples taken from people with FAP, and found the 2 bacterial species again. Then the team tried a mouse experiment, giving the animals a cancer-causing agent to elicit changes in the DNA of colon cells and then infecting them with one or the other of the bacteria. There were few or no tumors. But when the researchers infected the animals with both types of bacteria, tumor growth took off. The results might help explain why people with FAP, even individuals in the same family, can develop colon cancer at very different ages. Patients who get the disease early may be carrying these 2 bacterial species. Now Dr. Sears is trying to find out whether the bacteria always, or sometimes, are drivers of colon cancer in the general population. Working with nearby community medical practices, she is examining colon tissue from every patient having a colonoscopy. She hopes to review 2,000 pathology samples. But, she and others warn, it is premature to think of using the current results to protect people from cancer. You could try to eliminate the bugs, Dr. Joe Ben said. That is easy to say, but hard to do. Antibiotics will probably do more damage than good. The drugs kill a wide variety of bacteria in gut, he added, many of which are needed for health. The bacteria described in the new study are not the first implicated in colon cancer. Researchers have discovered a different type, Fusobacteria, in more advanced colon cancer. In a recent study they reported that Fusobacteria had burrowed into tumors and stayed with them as they spread throughout the body.